Hello there, I will now be working through the Chapter 4 practice test. First question is about evaluating sine, cosine, tangent, cosecant, secant, and cotangent. So, the first question has us evaluating sine of 4 pi over 3. So on the unit circle, 4 pi over 3 is just pi plus pi over 3. And so that means that I'm going to be right here on the unit circle, going right pi and then another pi over 3, which is 60 degrees. So the coordinates of this point are going to be negative 1/2, comma, negative root 3 over 2. And then my sine is the y value. So negative root 3 over 2 is the answer. Next, 7 pi over 4. That's just 2 pi minus pi over 4. So I'm going to be right here. And the coordinates at that point are root 2 over 2, comma, negative root 2 over 2. And so my cosine is the x value. So the answer is root 2 over 2. 3 pi over 2 is pi plus pi over 2. And so I'm going to be right here on the unit circle. The coordinates are 0, comma, negative 1. And tangent is sine over cosine, so that's the y value divided by the x value. So it's negative 1 divided by 0, which is undefined. Next, I have 5 pi over 3 again. I didn't do that yet. 5 pi over 3 is just 2 pi minus pi over 3. So that's going to be right here on the unit circle. That's 1/2, comma, negative root 3 over 2. And cosecant is 1 over sine, so it's 1 over the y value. So 1 over negative root 3 over 2, which is negative 2 over root 3, which is negative 2 root 3 over 3, rationalized. Next is 5 pi over 4, secant. I think we did that earlier, right? No, we didn't. 5 pi over 4 is just pi plus pi over 4. So that's right here, which will be negative root 2 over 2, negative root 2 over 2. And secant is 1 over cosine, so that's 1 over x, which is minus root 2. Next question, 7 pi over 6, cotangent. Now that's just pi plus pi over 6. So it's right here on my unit circle. And that will be negative root 3 over 2, comma, negative 1/2. And cotangent is cosine over sine, so that's x over y. So that'll be negative root 3 over 2 divided by negative 1/2, which is root 3. Next, 13 pi over 3. Now this is larger than 2 pi, so I'm going to have to subtract out some multiple of 2 pi. And I'm allowed to do that because the period of the sine function is 2 pi. Here I'm going to subtract 4 pi, because 13 pi over 3 is slightly larger than 4 pi. And that's going to give me pi over 3. So I know that sine of 13 pi over 3 is equal to sine of pi over 3, which I know very well. It's right here. The coordinates are 1/2, comma, root 3 over 2. Sine is my y value, so the answer is root 3 over 2. Same for negative 15 pi. Here I'm going to add a multiple of 2 pi, which would be 16 pi. Notice how I couldn't just add 15 pi, because that's not a multiple of 2 pi. It's only an odd multiple of pi. So I have to be adding a multiple of 2 pi, and here I've chosen 16 pi. That's going to leave me with pi. So cosine of negative 15 pi is going to be equal to cosine of pi, which is right here. And that's negative 1 comma 0, so the answer is negative 1. Negative 11 pi over 6. Here I'm probably going to be adding 2 pi, which will leave me with pi over 6. So that's right here. and those coordinates are root 3 over 2 comma 1/2. And so the answer is sine over cosine, which is 1/2 divided by root 3 over 2, which is 1 over root 3, or rationalized, that's root 3 over 3. Next is 31 pi over 4. Here I will probably subtract 8 pi, which will leave me with negative pi over 4, which is right here. And that's negative root 2 over 2. Sorry, it's positive root 2 over 2, comma, negative root 2 over 2. And so cosecant is 1 over sine, so that's 1 over negative root 2 over 2, which is negative root 2. Let's continue to the next question. We have to find two values of theta between 0 and 2 pi that satisfy each equation. If secant theta equals 2 root 3 over 3, then that means cosine theta must be the reciprocal of that, which is root 3 over 2. So we're looking for 2 points on the unit circle that have an x-coordinate of root 3 over 2. So that's here and here, which will be pi over 6 and 11 pi over 6. So those are our two answers. Okay, note how both points have x-coordinate root 3 over 2. Next question has us evaluating cotangent theta equals negative root 3 over 3. So negative root 3 over 3 is just negative 1 over root 3. So there are two possibilities. Cotangent is just cosine over sine. So either cosine over sine is equal to negative 1/2 over positive root 3 over 2, or positive 1/2 over negative root 3 over 2. So that tells us that we are at either one of these 2 points on the unit circle. Okay? Either the x value is negative 1/2 and the y value is root 3 over 2, which is right here, or the x value is positive 1/2 and the y value is negative root 3 over 2, which is right here. And so that corresponds to 2 pi over 3 and 5 pi over 3. Next one, if cosecant theta equals negative root 2, then that means sine theta is equal to negative root 2 over 2. And so we're looking for 2 points on the unit circle with y value negative root 2 over 2. That's here and here. So that's 5 pi over 4 and 7 pi over 4. Tangent theta equals 0, then that simply means sine theta equals 0, because tangent is just sine over cosine. So in order for that to be 0, either we have 0 over 1 or 0 over negative 1. And so we're really just looking for 2 points on the unit circle with y coordinate 0. That's going to be here and here, which is 0 and pi. Next question has us determining the quadrant of theta. Okay. So first question, if tangent is negative, then that means x and y have different sign, because tangent is just y over x, sine over cosine. So in order for that to be negative, x and y have to either be positive negative or negative positive. But this second condition tells us that the sign is positive. So we conclude that cosine must be negative, or I can write this more clearly. If sine is positive, then y is positive, so x must be negative. So that puts us in quadrant 2, where y is positive and x is negative. Next, if cotangent is positive, then x and y have same sign. If secant is negative, that means cosine is negative. So x is negative, which means y must also be negative. So we're in quadrant 3. Okay. If sine is positive, then that means y is positive. But if cosine is negative, that means x is negative. So once again, we're in quadrant 2. Finally, if tangent is positive, then that means x, y have the same sign. And if secant is positive, that means cosine is positive, which means x is positive. So x and y are both positive, which means we're in quadrant 1. Next is a graphing question. Both of these graphing questions are not so easy because we have both vertical shifts and also horizontal shifts. That can be a little tricky. So a good idea is to start off by listing all of the different characteristics of our graph, period, maximum, minimum, etc. So here, actually maybe the best first step is to factor the inside of the parentheses. Of course, it is only by factoring the inside of the parentheses that we can actually correctly determine the horizontal shift. So here, the horizontal shift is not pi over 2. We first have to factor this as 3 pi over 4 times x plus 2/3, which you can check for yourself, and then plus 2. So this tells us that the horizontal shift is 2/3 to the left. Okay, it's only by factoring that you can determine the horizontal shift amount. Let's start by finding the period. So our b value, which is our coefficient of x, is 3 pi over 4. So that means that t is equal to 2 pi over b, right? That's true for sine, cosine, secant, cosecant. Not true for tangent and cotangent, but it's true for sine. And so t is equal to 2 pi over b, which is equal to 2 pi over 3 pi over 4, which is equal to 8/3. 8/3. So we found the period. Next, maybe it's good to find the shift. The shift is 2/3, right? Only after factoring. And it's 2/3 to the left. The reason why it's left is because we have a plus sign. Okay. Next, we can find the average. The average is 2. It's always the constant that is being added at the end or the beginning. The average is 2. And so the maximum is the average plus the amplitude, which is 4. So that's 6. And the minimum is the average minus the amplitude, which is -2. And so now with all this information, we're able to start graphing. For more information about the graphing technique, there's another video that I posted earlier. What I do is I first construct the lines for the maximum and the minimum and the average. So my maximum is 6. It's best to draw these proportionally to scale. My minimum is going to be -2, which is right here, and my average is 2. So next I'm going to draw some dashed lines to indicate these particular values on the graph. Next, I'm going to draw one period on both sides of the y-axis. So on the right side, I'm going to go out to 8/3. That's one whole period. And then on the left side, I'm going to go out to -8/3. Then I am going to construct the quarter period tick marks. So I'm going to split each period into 4 sections by drawing 3 different tick marks. And then I'm going to label each tick mark. So each tick mark comes in intervals of 2/3, because that's a quarter period. So this is 2/3, That's 4/3. Next one is 6/3, which is also 2. And I can do the same on the negative side. All right. Now I'm ready to start graphing, but first I need to determine where the shift is going to occur. So that's very tricky, isn't it? So this is a negative sine function, which means that I know that without the shift, so green is minus sine without the shift, okay? And I know that negative sine functions are going to intersect the y-axis with a negative slope. And so that's why I've drawn that line there indicating that it's going to intersect the y-axis with a negative slope. So it's downward facing tick mark. Okay. Next, I've already determined that the shift is going to take this function 2/3 to the left. And so 2/3 to the left simply brings me to this next tick mark over here. So I know that my real graph must intersect the average line, or 2, at x equals negative 2/3 because of that shift. Now, armed with this information, I'm able to determine where the graph is going to be at every single quarter period tick. So because I know that it's going downwards at this point, I know that at the next quarter period, which is at x equals 0, it's going to be intersecting the minimum at the y-axis. So then I know it goes in the order that I already know, which is dip, and then intersection, and then peak, intersection. So I know it's going to go like so. The same on the other side. And now all I need to do is simply connect all of these dots. And so I'm done. I'm going to do the same process for this next graph. The first step is probably to factor the inside of the parentheses. So that's going to give me -3 cosine, and then I'm going to factor out 5/3, factoring out the b value. 5/3 times x minus 3 pi over 5. Right? If you're confused about how to factor, all I did was divide pi by 5/3, which gives me 3 pi over 5. And then finally plus 1 at the end. So this helps me correctly find the horizontal shift, which is 3 pi over 5. First, the b value is 5/3. So that means t is equal to 2 pi divided by 5/3, which is 6 pi over 5. Next, the horizontal shift is 3 pi over 5 to the right. Next, the average is 1. And then the maximum is just the average plus the amplitude, which is 3. So the maximum is 4, and the minimum is the average minus the amplitude, which is -2. Now I can graph. I'm going to first graph the maximum and the minimum and the average. All right, and now I'm going to draw the horizontal tick marks. So each period is 6 pi over 5. So I'm going to draw one period to the right and one to the left. Then I'm going to draw the quarter tick marks. Now 1/4 of 6/5 is just 3 pi over 10. So here is 3 pi over 10, here is 3 pi over 5, and then here is 9 pi over 10. Same is true for the negative side, negative 3 pi over 10, negative 3 pi over 5, and negative 9 pi over 5. Sorry, negative 9 pi over 10. All right, now I can do the horizontal shift. So I'm first going to draw where it intersects the y-axis without any horizontal shift. So I know that a negative cosine function without a shift, I know that it's going to have a dip. I know that it's going to be encountering the y-axis with a dip, and it's going to happen at its minimum value. And now I also know that my graph is being shifted by 3 pi over 5 to the right. So I'm going to draw that shift, 3 pi over 5 to the right, which means that my new graph must have a dip at 3 pi over 5. And then I can fill in the rest of the intersections using the pattern that I'm familiar with. And then my final step is simply connecting all of these dots. That completes my graph. So in order to have full credit, all of these elements must be present. And I also wanted to go over some examples of what would be poor graphs or common mistakes that people make in terms of the actual sketching of the graph. So I'll have those in perhaps purple. A frequent mistake that people make is having the intersections go through the x-axis instead of the average line. It's very important to note that at these quarter period marks, the intersections must occur at the average line. So a graph that looks like this would be wrong, because those quarter period intersections go through the x-axis, which is not where they should be going. Likewise here, a wrong graph would look like this. So some things as I'm grading that I'm going to be checking for are to make sure that all of these x-axis tick marks are labeled with the correct values, because that indicates to me that you know the period. I'm also particularly interested in where it's intersecting at every single quarter period mark. So I'm checking to make sure that it has a peak, for example, at negative 6 pi over 5. I'm making sure that it's intersecting the average line at negative 9 pi over 10, and I'm making sure it has a dip at negative 3 pi over 5. Especially important is where it's intersecting the the y-axis. If, for example, it did not have a peak at the y-axis, or perhaps it intersected the y-axis at maybe the average line instead, then it would be quite wrong. And then finally, I'm looking for correct values for this maximum, average, and minimum line. Personally, I would recommend doing this process in exactly the way that I have done, making sure to construct the quarter period tick marks and these maximum, minimum, and average lines, especially the average line, which I think is very important for drawing a correct graph. If you don't follow those steps, I think it's very likely that you will lose points. Next, let's go into some questions that ask us to identify equations given a graph. Now here, the first step is perhaps to identify the period. So clearly here the period is pi over 2, because that's the distance between every single peak. So the period is pi over 2, which means that b is equal to 2 pi over t, which is 2 pi over pi over 2, which is 4. Next, this question is asking me to find a positive cosine function, and indeed, the graph is also a positive cosine function because it intersects the y-axis with a peak. The next step is to figure out the maximum and the minimum and the average. So the maximum here is clearly 5, and the minimum is -1. So that means the average is 2. And then the amplitude is just the maximum minus the average, which is 3. So my answer is 3 times cosine of 4x plus 2, because the amplitude is simply the a value, or the absolute value of the a value, and the average is simply the amount that is shifted by vertically. I also know it's a positive 3 cosine, because this is a graph of a positive cosine function and not a negative cosine function. So this is my answer. The next question is tricky because it has a horizontal shift going on, because the question is asking me to find a sine function when this graph clearly indicates a cosine function. So that means that I know there's some shifting going on. The first step is to find the period. So the period is pi over 6, because that's the distance between two peaks, which means that b is equal to 2 pi over pi over 6, which is 12. Next, I'm going to find the amplitude. Amplitude is clearly just 2, because the maximum is 2 and the minimum is -2. And then my next step is to find the amount that's shifted by. So if I'm starting from a positive sine function, which is what I'm looking for, then I know that my shift, or I know that my original sine function, without any shifting, must have intersected the y-axis at the origin, going upwards. And so to me, this looks like a shift to the left. So a shift left by, it seems like 1/4 of pi over 6, which is pi over 24. And so that tells me that my equation is going to look like this. -2 times sine of b parentheses x plus pi over 24. Now it's extremely important to have these parentheses. So the answer is going to be 2 sine 12x plus pi over 2. Please note that this is a wrong answer. What I'm about to write would be a wrong answer. 2 sine 12x plus pi over 24 is totally different, and that's wrong, because you did not factor the inside of the parentheses prior to writing the horizontal shift. The horizontal shift, both for identifying equations and also graphing equations, is only valid when you have the inside factored such that the coefficient of x is 1 within its parentheses. So please note that 2 times sine of 12x plus pi over 24 is wrong. Now there are also some equivalent answers that would have also been accepted. 2 sine 12x plus 5 pi over 2 is also good. Or 2 sine 12x minus 3 pi over 2 is also accepted. And of course, these simply exist because of the 2 pi period of the sine function. Some other answers that would have been accepted, which you can find for yourself, are negative 2 times sine of 12x minus pi over 2, or negative sine 12x plus 3 pi over 2. All of these would have also been correct. Okay, next question. Our next question has us looking at a secant or cosecant graph. So the best first step is, of course, to draw in the corresponding sine or cosine graph that corresponds to this graph. And so to do that, we simply draw this graph as if it were so-called kissing this secant or cosecant graph, as so. And then the various coefficients that we determined for this graph can simply be transferred over to our secant or cosecant function. So for this, what we know as a negative cosine function, for this graph, the minimum is -1, and the maximum is 3. So that tells us that the average is 1, and the amplitude is 2. Next, I know that the period is 12 pi, or the distance between 2 dips or 2 peaks. So the period is 12 pi, which means that b is equal to 2 pi over 12 pi, or 1/6. Finally, I know that this is a negative cosine function, so the graph of my cosine function would be -2, which is my amplitude, -2 cosine bx, or 1/6 x, plus 1, my average. And therefore, the answer for my secant graph, well, I know it's secant because that's what corresponds to cosine. The answer is just going to be -2 secant x over 6 plus 1. And so I'm done. Next, I have a tangent function. And this one's tricky because there's also a horizontal shift. So it might be helpful first to label some of these tick marks. This is pi over 2. This is negative pi over 2. And this is negative 3 pi over 2. That tells me that my period is pi over 2 minus negative 3 pi over 2, right? Because we can simply determine the distance between these two intersection points. So that means my period is 2 pi. Now b is pi over t. Note that it's not 2 pi over t, because now we have a tangent function. The equation is b equals pi over t. So b equals pi over 2 pi, which is 1/2. Next, I need to find the horizontal shift. I know that my positive tangent function is going to intersect the x-axis with a positive slope. And so I know that it's being shifted by pi over 2 to the right. Pi over 2 right. Therefore, my final function is tangent of 1/2 times x minus pi over 2. Note that it's a minus sign because it's a shift rightwards. And notice how I also expanded, or I have this factored form, because without the factored form, I'm not going to have the horizontal shift calculated correctly. So my final answer is going to be tangent of x over 2 minus pi over 4. Some other acceptable answers would have been tangent x over 2 plus 3 pi over 4. To find that, that could have also just been a shift by 3 pi over 2 to the left, which would have given you plus 3 pi over 2, and then multiplied by b, that's 3 pi over 4. So that's another acceptable answer. Next, we have some questions asking us to evaluate various inverse trig functions. Here, it's very important that we are careful about noting the range of these various inverse trig functions. Because of the range, there is actually only one correct answer for every single question. So if you didn't get the same answers, it would be wrong. Unlike some of the previous questions where there could have been multiple mathematically correct answers. The first question has us finding arcsine of negative root 3 over 2. So we're looking for a point on the unit circle with a y-coordinate of negative root 3 over 2. And so it looks like it's going to be that point. And that point corresponds to negative pi over 3. So that would be the answer. Okay? Now, note that this point also has a y-coordinate of negative root 3 over 2. But that would be wrong because it does not fall within the range of arcsine, which only gives us angles in quadrants 1 and 4. So the range of arcsine is between negative pi over 2 and pi over 2. So there's only one correct answer, which is negative pi over 3. So note, negative 2 pi over 3 is wrong. So is 5 pi over 3. Even this point here is technically equivalent to 5 pi over 3. 5 pi over 3 does not lie within the range of arcsine, which is negative pi over 2 to pi over 2. So these answers would all be wrong. Next, we have arctangent of root 3 over 3. So using some of the techniques we used before, we know that root 3 over 3 for tangent corresponds to this point. I'll write it out. That means tangent theta equals 1 over root 3, which is equal to root 3 over 3. And so in order for that to be true, we must have 1/2 divided by root 3 over 2 as our coordinates. So that tells us that sine theta is 1/2 and cosine theta is root 3 over 2. So the coordinates of our point must be root 3 over 2 comma 1/2, which places us at pi over 6. Okay? So the arctangent function has the same range as our arcsine function, which is quadrants 1 and 4, negative pi over 2 to pi over 2. Notice how this point also has tangent root 3 over 3, but it's outside the range of the arctangent function. So, in other words, 7 pi over 6 is wrong. Next, we have arc cosine of negative root 3 over 2. So that means we're looking for an angle theta now between 0 and pi, or quadrants 1 and 2, which has cosine theta equals negative root 3 over 2. So we're looking for a point that has x-coordinate negative root 3 over 2. That's going to be this point here, which is 5 pi over 6. Notice that this point also has cosine negative root 3 over 2, but it would be wrong because it's not within the proper range of the arc cosine function. Next, we have arc cosine of 0. So we're looking for a point with cosine theta equals 0, which means that it has x-coordinate 0, which is the point pi over 2, which indeed falls within the range of our arc cosine function. Next, we have arctangent of negative 1. So we're looking for theta such that tangent theta is equal to negative 1, which means that either we have negative root 2 over 2 over positive root 2 over 2, or positive root 2 over 2 over negative root 2 over 2. So on the unit circle, that corresponds to either this point or this point. But remember that the arctangent function has a range of quadrants 1 and 4, negative pi over 2 to pi over 2. And so the answer must only have this point, which would be negative pi over 4. So this point would be wrong. 3 pi over 4 is wrong. But this would also be wrong if you had written 7 pi over 4, which technically is also this point, but it lies outside the range of our arctangent function, which is negative pi over 2 to pi over 2. So these are wrong. Our next 4 questions have us evaluating compositions of inverse trig functions and trig functions. The first question is cosecant of arctangent of negative 2. Now, we know that the range of arctangent is quadrants 1 and 4. So what we're going to do is construct this arctangent on the coordinate plane. So we're looking for a value of theta such that tangent theta equals negative 2. And then our final answer is going to simply be cosecant of theta. Okay? In other words, to say it more clearly, if theta equals arctangent negative 2, then tangent theta equals negative 2. And all we're simply looking for is cosecant of theta.
Hey.
Hello, I'm recording a video, by the way. It's okay. It's about 50 minutes into the video already, so probably nobody's watching. So, tangent theta, arctangent has range of quadrants 1 and 4, so that means if tangent theta equals negative 2, it's probably going to be in quadrant 4. So if this is theta, then tangent theta is negative 2, so tangent is opposite over adjacent, so this side would be negative 2 and this side would be positive 1. So note how this side must be negative 2 and this side must be positive 1, because we know that it has to be either quadrant 1 or 4. So something like this would have been wrong. Something like this, where this side is positive 2 and this side is negative 1, that would have been wrong because that's in the wrong quadrant, which is not within the possibilities for arctangent. So it has to be this one. And so if those two side lengths are 1 and -2, then our hypotenuse must be root 5 by the Pythagorean theorem. And so that means cosecant of theta would be root 5 over -2. So it's negative root 5 over 2 would be the answer. Next one, arcsine of 14 pi over 3. Now, what would be incorrect is if you just simply wrote 14 pi over 3, is because that is outside the range of our arcsine function. So what we have to do is convert this into an angle that is within the range of arcsine. So a good start would be to subtract a multiple of 2 pi and see if that yields an angle within our proper range. So I'm going to subtract 4 pi because 14 pi over 3 is slightly greater than 4 pi. So when we subtract 4 pi, we are left with 2 pi over 3. Now, if we plotted that on the unit circle, 2 pi over 3 is 120 degrees, and so we know that this point would be right here. Unfortunately, that's still outside the range of our arcsine function, because arcsine can only be quadrants 1 and 4. And so what we have to do is find a equivalent point on the unit circle that yields the same y-coordinate of the for its sine value. And so that's going to be this point here. So this point is 2 pi over 3, and this point is pi over 3. So note how these points have the same y-coordinate. So they're going to share the same sine value. And so that means that the answer is pi over 3 and not 2 pi over 3. Alternatively, you could also simply compute it sine of 14 pi over 3. Sine of 14 pi over 3 is root 3 over 2. And then you could have just done arcsine root 3 over 2 and determined that to simply be pi over 3. So it's kind of the equivalent way, but just actually calculating out sine of 14 pi over 3. And that could be helpful if we're reducing some errors in terms of getting the right angle in the end. Next, we have cotangent of arccosine of x. So we simply draw the triangle. We're looking for a value of theta such that cosine theta equals x. So that means that the adjacent side has to be x and the hypotenuse would be 1, which means that the remaining side would be 1 minus x squared, and square root of that. So that means that cotangent of theta is equal to x over root 1 minus x squared. And I'm done. Next, I have to evaluate tangent of arcsine of -1. So the arcsine of -1 is negative pi over 2. Unfortunately, here it's a little hard to actually construct the right triangle because it vanishes. So it's easiest just to simply think about what the arcsine would be numerically. Right, we're looking for a point on the circle with y-coordinate -1, so that's only this point, which is negative pi over 2. And so the tangent of that, tangent negative pi over 2, would be -1 over 0, which is undefined. And so that would be our answer. And the final question will be an extra credit question, so that concludes this video.